Have you ever thought about how our school system may not portray students fairly, and yet is our number one system for judging their potential? Our project digs into how unfair it is for students with a lack of resources to succeed in school and to be fairly assessed. We had sympathy for those with low family support, health issues, financial issues, and many others which get in the way of their best performances. If these external issues continue to affect how we view students' capabilities to learn and grow, we are also limiting ourselves to only accept those with sufficient background resources when it is not decided by neither choice nor skills. To begin this research, we looked at our student data that also contained each of their backgrounds. We ran some issues involving not being able to convert features into numeric values and data set not sufficient enough for training the logistic regression model.
All right, so basically we have this causal model that we have on the middle of this presentation. This shows the loose correlation to G1, G2, the first and second trimester grades, which is then strongly correlated to G3. That's the background information, and with the given data from UCI, we are computing the bias and fairness within the data within 5 steps. So first of all, creating a causal model is the key point, which then shows the correlation between all these different features that we have. And then with these given data points, we had to clean up some of the values from string features to numerical features so we could put it into our model, which then pipelines into our third step, which is training the model, which we then took some of the data and did an 80-20 split where we trained the model. And then after training, we thresholded all the labels and thresholded the G3 scores on a moving scale from 1 to 20 in order to get the optimal threshold values. And fifth step, we then visualize the data by plotting all these results onto the ROC curve.
After we trained our model, we generated ROC curves, which plotted the thresholds from 1 to 20 and the false positive versus the true positive rates. And we compared our logistic model that was trained on the raw data with the model that was trained on the synthetic data. And what we noticed from these ROC curves was that there was a very real problem of not having enough data to produce a sound ROC curve. And even when we generated the synthetic data to have a large enough sample size for our model, we were actually indirectly introducing bias. In our raw data, our model was biased towards academically excelling students, which means that it placed a threshold where students required a higher grade to pass the class. And in our synthetic data, the model placed the threshold lower on the curve, which allowed the model to be more lenient on passing students. So the optimal threshold should exist somewhere along the middle of the ROC curve. But because of our results, we were unable to determine the real effects of the features in the causal model. And this is a real problem that some potential user might encounter when they are attempting to predict whether or not the student will pass the class based on the features that were given to them. In our future work, we could investigate the process of forming grades that makes them unfair. We could potentially provide a method to enable inclusiveness in student potential instead of concluding with just the student's academic success, whether or not they passed or failed.